On guided practice on page 272, we have a table on number 1 that represents the number of days and the total number of text messages. So number of days, total messages per day, 1, 2, 3, and 4 days. Starts out at 50 messages, goes to 100, 150, and 200. Well, you can see that the rate of change here is 50 from day to day, an average of 50 messages. And your days are just 1 per day. So your rate of change is 50 messages per 1 day, right? Now, rate of change is also known as your slope. And if we look at the rate of change, if it's constant, it'll be a linear relationship. And we can say that the number of messages is equal to the rate of change, which is 50 messages per day times the number of days. Okay? So as you can see, when I plug in the D, the two D's will cancel out and we'll end up with messages. So they ask for the number of messages in 30 days. So we're going to plug in 30 for D. Oops. 30 for D. And we find that the total number of messages in 30 days is 1,500 messages. What? 50 times 30. They ask you to describe the relationship in words. And you can say that he sends an average right here. Brad sends an average of 50 messages each day. They just want you to be able to put it in words. Okay, so now we can look at number 2. And we have the graph showing the amount of money the Rockwell family budgets for food each month. Write an equation to find the total amount of money budgeted in any number of months, M. Use the equation to determine how much money the Rockwell family should budget for 12 months. So the total amount of money, C, is equal to the amount of money that they should budget per month. Okay? And they're saying here, if we look at the graph, they're going up 625 each month. So month 1, 625, month 2, 1,250. So the rate of change is 625 per month. Okay? And so if we put in the number of months, we'll be able to see how much they would be able to save. And in this example, they want you to find out how much the family will make if they budget $625 for 12 months. And we get $7,500 budgeted in 12 months. And finally, in number 3, we have a store receives an average of 7 new movies per week. First, they want you to write an equation. So number 3A, they ask you to write an equation. And they say 7 new movies per week. That means the rate of change is 7 per week, right? Movies per week. Seven movies per week. So we can write an equation that the number of movies they watch is equal to the rate of change, 7 movies per week, times the number of weeks. That's all they wanted for A. In B, they asked to make a table to find the number of new movies received in 4, 5, 6, and 7 weeks, and then graph the ordered pairs. So if we make a table, we can do it like they do in the book, and we have weeks, 7 per week, and the number of movies. So if we do 4 weeks, and we're doing 7 for 4 weeks, that would be 28 movies. 5 weeks would be 35. 6 weeks would be 42, and so on. Now, when you go to graph that relationship, you're going to do the number of movies Remember in our last chapter, this was a y. So that's why the movies, this variable is going to be the y-axis. And then the number of weeks is your x value. So now they want us to graph the ordered pairs, and we've got 428, 535, and 642. So if we graph those coordinate pairs, they didn't say to make a line, they said to just graph the ordered pairs. So if we do 1, 2, 3, 4, 5, 6, 7, we can do that for the weeks. And then we can look at the number of movies. We've got to go up at a greater value. So we could maybe do 10, 20, 30, 40, 50, 60. That way it'll be easier to graph. And if we do 4 weeks at 28 movies, we'll be about right here. And 5 weeks at 35 movies. And 6 weeks at 42 movies. So you can see that it's a linear relationship, and those dots are forming a line.